Hello, this is Group 3, live from San Diego, Idaho, as always.
No cheesy joke
We gotta
today.
look for like 100 San Diego jokes.
Any cheesy jokes?
Like your
What did... Oh, how does Harry Potter walk down a hill?
JK.
He doesn't. JK, he rolls. One second, I gotta answer this. Hello? This is, yeah.
Are you kidding me?
Good thing we're not in a group meeting right now.
Seriously.
Can you hold on for just a few seconds?
I'll just start without him.
Yeah, guys, just start without me, and I'll come in like 2 minutes. Sorry.
Is that, who
Just
is
like
that?
a job interview?
It's my doctor.
Oh, you're gonna die. You're fine.
Sorry about that.
So number 1, false.
Yep. Same with number 2.
All right.
Did you know number 3? Or
What
do you know number 3?
must be checked when conducting a hypothesis test comparing two means with independent samples. A simple random sample must be drawn from each population. X is normally distributed for each group. The mean is greater than 0.
No,
That's what
in Idaho still,
What was that?
the sample
but
size
I
is
like to
the
see
same for each
competition
group.
in San Diego. And if I have to fly home for appointments and Remington, and the problem is because my parents.
I think Matt should have muted.
Get out the room, bro.
Stop talking about your special cream out loud.
But when
Yeah,
it's
mute
used
that.
to realize that here,
Gosh.
Idaho and Utah are no longer covered
All right.
by service, so it just kind of blindsided.
So I think it's the first one or the last one.
Well, it's multiple.
Oh, it's multiple.
Yeah. So I had
Yeah,
put
the
the
Remington
first and the last.
So I think
But-
first one for sure. Let's see if the sample size even matters.
Well, I think I actually have Remington.
I put the first, second, and last one, but I'm not.
Yeah, I can
I
see.
don't think that.
Yeah.
I don't know.
Yeah, I think they. Do they though?
Right.
Let's put it
We can go back to that one.
distributed. Control F. I feel like everything just has to be normally distributed.
Mhm.
All right, number 4.
Right.
The test statistic for a hypothesis test
Right. It's actually not that.
with independent samples is Z, T, or F. So it's either Z or T.
No,
Yeah, because what did they say? It's either Z or T.
The first one or the second one.
I don't think it's T score because that's not for independent samples. That was for the matching ones, wasn't it?
T. What's this called? Oh, test statistic. I still think it's the test statistic for a hypothesis comparing to an independent is T. Yeah, it's T.
What the heck?
Yeah, I have the card.
Hey, mute yourself.
No, I'm doing some home.
Hey Matt, you can hear this. Mute yourself.
But this is more important.
I like how you put them on speakerphone too.
Yeah, what about it?
All right. Two samples are independent if knowing which subjects will be in group 1 determine.
Tells you nothing about the subject. I think it's the second one.
I'm just trying to see where it's actually. I actually have a picture of it, so I'm trying.
All right. For the next 6 questions, that sounds good.
And I talked to Elijah yesterday, and I think, or maybe it was someone else that said something like there was an appointment on March 6th, I think.
Matt. It's like he thinks that since he's not in the picture, we can't hear him.
He does have a good microphone that we're picking this all up.
Yeah, that's pretty good.
He has sucky speaker. He probably turned his volume down.
That's why I came over to the computer.
I almost can guarantee he can't hear us.
All
Matt,
right.
if you can hear me, I'll give you $50. And Mason will give you his truck.
Oh yeah,
He can't hear us.
he'll take the payments on.
All right. So I got 19 for 6.
And then I got
The item number is
6.637 for 7.
206,637?
Yeah,
All right.
I'm gonna do it too.
51481.
Test statistic. U1 equals U2. Okay. Well,
Yeah.
I didn't look at the sample problem on this one.
Letter H, Bloomfield.
Are you doing 8 right now?
Yeah, so to find the test statistic,
You have to get the mean of the differences, and the mean of the differences is negative 28.538.
do you subtract them?
You subtract. You do the first set minus the second set, and then you find you find the average of the differences.
Is that what you do for this one, or are you thinking of what we did for the last one?
Oh, I'm thinking of the last one.
Yeah, I feel like in the last year and a half, I've got my brother Katie, I've been playing sports, I've been healthy.
It might make sense
I haven't
though.
had a flare up or anything.
That they equal each other. U1 equals U2.
Dude. He's so loud. Isn't it the same thing?
They should equal each other. We texted him.
There he goes.
Dude, I got a Fitbit Blaze. It's pretty cool. Tells me when I get texted.
Oh, that is cool. It's like an iPhone knockoff. I mean, iWatch, what do they call them? Apple
Yeah,
Watch.
these ones are better workout, but worse smart ones. But it's kind of nifty that it tells me when you guys text. Because my phone's on silent, but it vibrates my wrist.
I don't see a point in being able to text on your watch when that screen is so small.
It's like small, so like, okay. Like small stuff. Like if you could talk and be like, "Hello, how are you doing?" That'd be kind of cool. But
Yeah.
it's not worth the extra $100 for the watch. Test statistic. How do they do this? Maybe let's just try putting the data into this worksheet real quick. What was N? 19?
Huh?
N was 19. What was the mean?
Oh, yeah, it was 19.
And then what was the mean?
And the standard deviation, you mean?
No, the mean.
The difference of means? I mean,
280.597.
You're talking-
288. And then what was the standard deviation? 206,
0.637.
637. So I think the t-score might be 5.252.
And that's going off of the same way that we did it last week, right?
Yeah, the oh, this is a one sample t-test. Oh, that'll still work. That's right.
What did you get?
5.252.
All right.
So 5252.
5.2, yeah. And then I still don't really get p-value. I think we need Matt to.
All right. So I got, for a p-value, I got 0.999.
That's what you always get, though.
Oh, wait. Are we doing it? All right, we'll skip number 9 for right now.
Yeah, Matt. I think Matt understands now, and we can't do 10 until we get number 9.
So, and then can't do 11.
We'll just start again on the new one, the freshman dinner.
Okay.
I'll get the mean of the difference.
So what is the appropriate alternative hypothesis? I think less, I don't know.
They don't have the same amount of like population.
So I think it's not the last one. Number 3. I don't think sample size matters.
Yeah, that would make sense. Then how do you do the T score?
You do 2. Ooh. I only did the t-score for one of them on that up above. Maybe you do subtract them.
Well, the standard, didn't I gave you the mean of the differences though.
I just used the mean from the Rexburg office.
Oh.
We'll come back to that one.
So we'll come back to which one did you say? The 12?
Pretty much that whole set of questions. We'll just do over with Matt, see if he. What is the test statistic, p-value?
Hey guys.
Hey,
Sorry
man.
about that.
So I think you're right, Mason. We're pretty much on 7, Matt.
You're on 7?
Yeah, we think we did it wrong, so we're going back to it now.
Okay.
Well, the standard deviation, we're on 8 because number 7 is gonna be right.
Oh yeah, number 8.
And so,
Which one was U1? Was it the Rexburg? I don't.
yeah, I think so. Yeah, it's Idaho Falls is 1. Aaron, when you calculated the test statistic, wait. Yeah, when you calculated it, did you plug in the mean of differences and subtract it from?
No, so I just used the mean from the Rexburg office. So do we just do Idaho Falls minus Rexburg, and that's our difference average?
You do for every single one of those bills.
Oh yeah, I did the shortcut. That's right.
You subtract each one, drag it down, and find the mean of those differences.
equals this minus this.
And then you drag it down and find the mean of that, and it's negative 28.538.
Negative 28.538.
Yeah. I was thinking the same as you to get the difference of the means instead of.
I think they were almost the exact same answer though,
Yeah.
but the standard deviation was way wrong. So you got negative 28.538,
Correct.
and then the standard deviation 299.304. 303.
For the standard deviation of what?
The two. That difference one.
Oh. What did you get? 299.303?
Now. Did you get a T value, Matt?
For 6 or
8?
8.
no, I'm still on 6.
6 is 19 because the sample size is 20, right? And you subtract it by 1.
Yeah.
Okay, yeah. I hadn't pulled them up yet. So 19.
Let's see.
And then on number 7, it's easy. You just do the standard deviation of Rexburg, which is 206.637. You get that, Matt?
Yeah, so I went with I'm just gonna type it in. Is it the top STD or the bottom one?
It's S, the bottom one. STDV. I don't know how it is. Equals STDV.
So you got 206 point.
637.
Yeah.
Okay, cool. And then to get T, did you use a formula or did you put it in the quantitative inference thing?
We did the quantitative inference.
Did you just put it in the one sample t-test?
Yeah. Oh, is this supposed to be this 2 sample?
It might be the 2 sample.
All right, so they're both 20 for N. The mean for this one is 2.
Do you guys just on the homework that I did the other day, I just copied and pasted the data into variable 1 and variable 2. Is that so what did you get for your t-score? Did you get negative 0.434?
Yeah. And then a p-value of 0.666 or 0.667.
Yep.
Hey, so can you explain how you do the p-value? I still don't understand how to do that.
You have the quantitative inference thing pulled up.
I don't have it pulled up, but I can.
It's just we put in the mean, the N, and the standard deviation, and then the t-score and the p-value pop up.
So you just fill it out and it does it for you?
Yeah.
Yeah. So the p-value I wrote this down the other day. The p-value is the probability that you'll get a t-score that's more extreme than the t-score. Probability to get more extreme. I think whatever t-score you put in for the p-value, the p-value is the probability that you will get something more extreme than the t-value you put in.
So, greater than or less than?
It just, well, it depends on what the question asks.
Oh, is this one reject the null hypothesis?
Yeah, this one was the this one was a not equal to. So if we were to look at that curve, that bell-shaped curve,
This
we
one
would
was
put,
U1 is less than.
is it?
Yeah, U1 is less than U2.
All right, I think it's reject. Let's go to 11. So suppose that you had used that instead. What could you make?
Suppose instead of the other.
What do you guys think?
I don't know.
Oh, not the third.
I think it might be the fourth one.
All right, I'm good with that.
I'm not sure because I feel like
I don't like these ones because I don't really get them.
yeah, I feel like the p-value. I don't know how you adjust the p-value in this one. You know?
Well, on the you can use the that Excel sheet, and if you can you can change the type of test.
Oh, okay, I see. Yeah, I was changing the words down below in the
No,
two.
there's a drop down list. You just you hover over, you click on the not equal to or whatever it's set to, and then there's an arrow, and you drop it down and then click it.
Okay. Yeah, I think the less than and the equal to, since they're both less than 0.1, which is the level of significance, basically it's saying the probability that the null hypothesis is wrong is less than the level of significance.
Yeah, we'll
That's
just
wrong. We'll come back. Okay. For the next questions, use the data file.
the next question. Would this one be U1 is not equal to U2?
Right.
Or did you guys already say that?
How'd you come up with that?
Because he's saying you suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. It's not saying more or less, which one's more and which one's less.
Oh, it's just not equal. Gotcha.
Yeah, and U1 equals I forgot which state.
So you just care that it's different, not necessarily which one's more.
Yeah. And then, but I don't know how to find the difference of the mean of the differences on this one because there's not the same amount of students that they examined. So I don't know if it's like, you know what I mean? Like because for the test statistic.
I just plugged it into that quantitative inference thing.
Oh, that's right. And this is a 2-sample t-test, right?
You guys, did you
Yeah,
get
this
two
is-
scores in that?
I got a t-score of 0.845.
All right, me too.
And a p-value of 0.411.
Yep. 0.411. So our p-value is greater. So we reject when it's greater, right?
Well, no, isn't the p-value less than? Oh no, it's 0.4, not 0.04. Yeah, failed to reject.
Oh, it's failed to reject?
Yeah, I'm pretty sure when the p-value is less, then we reject. But if it's greater, then we fail to reject.
Well, then I think we have to fail to reject on number 10 as well.
What did you do?
Oh yeah, because it's 0.6, not 0.0. I kept thinking it was 0.0.
So, yeah, if the p-value is greater, then we is that reject or fail to reject?
We think if the p-value is greater, then it's fail to reject.
Okay.
Now we're doing U1 minus U2.
So what'd you get for your margin of error?
I have no idea. I started to do something and then realized it's probably. Did you do the Utah boys minus Colorado boys and then do the average and standard deviation and all that?
No, all I did is on the quantitative inference, if you plug in the numbers or the values in the chart on the left, you can go to the confidence interval. Or the confidence level, you have to put it to 0.95. But then if you go to the confidence interval, you can take those two numbers, and from those two numbers, yeah, you can find the margin of error and you can find the point estimate.
So The margin of error is just the number in the middle, right?
Well, the number in the air, the margin of error is the distance from the number in the middle to one of the bounds.
So 5.148 plus negative 2.214 divided by 2. Did you get 3.681?
Yeah.
All right, save all responses. Was there one or two that we wanted to go back and check? Oh, number 3.
Hey, what'd you guys get for 16, 17, and 18? I was trying to figure it out.
3.681.
Yep.
Negative 2.214
Mm-hmm.
and 5.148.
Does yours say 5.41? Because mine says 5. Mine says 5.147. I don't know if it really matters, but
Mine says 8.
yeah, it's all good. I don't know why, but
All right.
3,
So
I think.
3.
I think it's the first, the second, and the last one.
It's not the last one because of the one we just did.
Yeah, there are different sample sizes.
So first and second.
That's what I have put.
19,206 negative. All right. And this bad boy.
Let's so what did we put for 4, Aaron?
1 second. Just closing these Excels really quick. Oh, maybe I shouldn't have closed them before we submitted it.
What did you put for 4, Matt?
4, I put T-score.
Yeah, I thought it wasn't T-score. Do you know why it's? Can you explain why it's T-score?
Well, I just Control F test statistic in the book,
Yeah.
and it says the test statistic for the hypothesis test comparing two means with independent samples is a T.
Well,
will use-
sounds good enough to me.
And then the other thing was we were finding the T-score for all these independent ones anyways.
Yeah. And then for 5, we did the second one. 6 was 19. 7 was 206.637. Negative 4.
Oh, that's weird. I'm back.
Did you end it?
No, it's still broadcasting, but I lost internet, so I switched over to the visitor internet.
And you didn't get booted out of our thing?
I guess not. That's kind of weird.
Because we were. Can you end it still?
I can end it. Are we done?
Yeah, we finished.